To determine the number of 20 amp receptacles permitted on a 20 amp breaker, refer to National Electrical Code section 350.12. To calculate the combined number of 15 amp and 20 amp receptacles on a single circuit, consult NEC section 350.1. A step-by-step guide will help you calculate the combined current. Firstly, convert 15 amp receptacles to equivalent 20 amp receptacles by multiplying the number of 15 amp receptacles by 1.25. Secondly, round up the converted current to the nearest multiple of 5 amps. Thirdly, add the equivalent 20 amp current from step 2 to the actual 20 amp receptacle current. Fourthly, compare the combined current to the circuit breaker rating, ensuring the combined current does not exceed the breaker rating. Here's an example to illustrate the process. Suppose you have 4 15 amp receptacles and 2 20 amp receptacles. Firstly, calculate the equivalent 20 amp current for the 15 amp receptacles by multiplying 4 by 1.25, which equals 5 amps, then round up to 5 amps. Secondly, calculate the combined current by adding the equivalent 20 amp current to 5 amps to the 2 times 20 amp, which equals 45 amps. Since 45 amps exceeds the 20 amp breaker rating, you cannot install all of the receptacles in the same breaker. The purpose of these calculations is to ensure electrical safety and prevent overloading circuits, which can lead to overheating, fire hazards, and damage to electrical equipment. Always adhere to the National Electrical Code guidelines and local electrical codes when installing or modifying electrical circuits. Calculating the load on a circuit is a fundamental aspect of electrical work, and it ensures the safety and reliability of the electrical system. Understanding how to determine the number of receptacles on a circuit and how to calculate combined loads is crucial for both residential and commercial electrical installations. The NEC provides specific guidelines and requirements to ensure that electrical systems are installed and operated safely. Firstly, the NEC sets standards for the size and type of conductors used in electrical circuits. Secondly, the NEC regulates the overcurrent protection devices, such as circuit breakers and fuses, that are designed to protect the circuit from overloading. Thirdly, the NEC outlines the proper methods for installing receptacles, switches, and other electrical devices. When calculating the load on a circuit, it is important to consider all of the devices that will be connected to the circuit. This includes lighting fixtures, appliances, and any other electrical equipment. Each device has a specific power consumption, which is typically measured in watts. To determine the total load on the circuit, you need to add up the power consumption of all the devices that will be connected to it. Once you have determined the total load on the circuit, you can then calculate the current that the circuit will draw. The current is measured in amps and can be calculated using Ohm's law, which states that current equals power divided by voltage. In the United States, the standard voltage for residential circuits is 120 volts. Therefore, if you have a circuit with a total load of 1200 watts, the current that the circuit will draw is 1200 watts divided by 120 volts, which equals 10 amps. It is important to ensure that the current drawn by the circuit does not exceed the ampacity of the circuit breaker or fuse protector in the circuit. The ampacity is the maximum amount of current that a conductor can safely carry. Circuit breakers and fuses are designed to trip or blow if the current exceeds their ampacity, thereby protecting the circuit from overloading. In the example above, if the circuit is protected by a 15 amp circuit breaker, it would be safe to connect the 1200 watt load to the circuit. However, if the circuit is protected by a 10 amp circuit breaker, it would not be safe to connect the 1200 watt load to the circuit, as the current drawn by the load would exceed the ampacity of the circuit breaker. In addition to calculating the load on a circuit, it is also important to consider the voltage drop in a circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Voltage drop can occur due to the resistance of the conductor and the length of the circuit. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. The NEC provides guidelines for limiting voltage drop in electrical circuits. These guidelines specify the maximum allowable voltage drop for different types of circuits and applications. To minimize voltage drop, It is important to use conductors that are large enough to carry the current without excessive resistance. It is also important to minimize the length of the circuit. When installing electrical circuits, it is important to follow all applicable electrical codes and regulations. These codes and regulations are designed to ensure the safety of electrical installations and to prevent electrical hazards. It is also important to use qualified electricians for all electrical work. Qualified electricians have the training and experience necessary to install electrical circuits safely and correctly. In summary, calculating the load on a circuit is a critical aspect of electrical work. By understanding how to determine the number of receptacles on a circuit and how to calculate combined loads, you can ensure the safety and reliability of electrical systems. Always adhere to the National Electrical Code guidelines and local electrical codes when installing or modifying electrical circuits. Furthermore, consider the specific requirements of the devices you intend to connect to the circuit. Some appliances or equipment may have unique power requirements or specific installation instructions. For example, large appliances such as refrigerators or air conditioners may require dedicated circuits to ensure proper operation. Similarly, sensitive electronic equipment may require surge protection to prevent damage from voltage spikes. In addition to the number and type of receptacles, also consider the location of the receptacles. Receptacles should be placed in convenient locations that are easily accessible. They should also be placed in areas where they are not likely to be exposed to moisture or physical damage. In areas where moisture is present, such as bathrooms and kitchens, ground fault circuit interrupter, known as GFCI, receptacles should be used to protect against electrical shock. GFCI receptacles are designed to detect ground faults, which can occur when electricity flows through an unintended path, such as through a person's body. When a ground fault is detected, the GFCI receptacle will quickly trip, cutting off the flow of electricity and preventing electrical shock. When working with electrical circuits, it is important to always take safety precautions. Firstly, always turn off the power to the circuit before working on it. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear appropriate personal protective equipment such as safety glasses and gloves. Fourthly, never work on electrical circuits when you are wet or standing in water. Fifthly, if you are not comfortable working on electrical circuits, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Understanding the principles of electrical load calculation is not only essential for electrical professionals but also beneficial for homeowners and anyone involved in electrical projects. By grasping these concepts, you can make informed decisions about electrical installations and ensure the safety and efficiency of your electrical systems. Furthermore, knowledge of electrical codes and regulations can help you avoid costly mistakes and ensure compliance with local requirements. The National Electrical Code is a comprehensive set of standards that covers a wide range of electrical topics. It is updated every 3 years to reflect the latest technological advancements and safety practices. Staying up to date with the NEC is crucial for electrical professionals and anyone involved in electrical work. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. These local codes may be more stringent than the NEC and may address specific local conditions or concerns. It is important to be aware of and comply with all applicable electrical codes and regulations in your area. Electrical inspections are typically required for new electrical installations and modifications to existing electrical systems. The electrical inspections are conducted by qualified electrical inspectors who ensure that the electrical work complies with applicable codes and regulations. Passing an electrical inspection is essential for obtaining a certificate of occupancy or other permits. Moreover, proper electrical maintenance is crucial for ensuring the long-term reliability and safety of electrical systems. Regular inspections and maintenance can help identify potential problems before they become serious hazards. Electrical maintenance tasks may include checking for loose connections, inspecting wiring for damage, and testing GFCI receptacles. In addition to safety, proper electrical design and installation can also improve the energy efficiency of buildings. Energy-efficient lighting, appliances, and electrical systems can help reduce energy consumption and lower utility bills. The NEC includes provisions for energy-efficient electrical design, such as requirements for lighting controls and energy-efficient motors. In conclusion, understanding electrical load calculations and adhering to electrical codes and regulations are essential for ensuring the safety, reliability, and efficiency of electrical systems. By taking the time to learn about these topics and by working with qualified electrical professionals, you can protect yourself, your property, and others from electrical hazards. This information should serve as a general guide, but it is always best to consult with a qualified electrician or refer to the latest edition of the National Electrical Code for specific guidance on electrical installations and calculations. Electrical codes and regulations can be complex, and it is important to have a thorough understanding of them before undertaking any electrical work. Remember to prioritize safety when working with electricity and always follow best practices for electrical installations and maintenance.